Okay, so we're doing some homework questions on sketching exponential curves and block curves. Okay, the equals to here just means that you have to plot both the left-hand side functions and the right-hand side function on the same grid. Don't let the equals to sign confuse you. Okay, so you need to know how to sketch square root of x. That always looks like this. So this is the graph for square root of x. Now we need to sketch 5 e power minus x on the same grid. So we know that e power x looks like this. This is 1 for e power x. E power minus x looks like this. It's a reflection on the y-axis. So this is e power minus x. That also passes through 1. However, 5 times e power minus x would pass through 5 here. So we make a curve like this, which intersects the y-axis at 5, and this is the graph for 5 power e minus x. This is for square root of x, and this is for 5 power e minus x equals y equals y. Next part is we have to sketch the graph for y is equals to e a power x minus 1. Okay, let's just first sketch the graph for e power ax. It's an exponential graph. It goes like this. When x is 0, e power 0 is 1, so the y-intercept is 1. Okay, but we have to subtract 1 from it. That means this graph goes 1 unit down. So the asymptote, which was originally this line at 0, will go 1 unit down, and we will draw the asymptote with a dotted line, and this is -1. Also, the y-intercept will also go 1 unit down, and it will now be at 0. So your graph would look something like this. This asymptote needs to be horizontal. Mine is slightly off. So fix that and we're done. This is the graph for y equals e power ax minus 1. All right, now we need to plot two graphs, y equals x, which simply looks like this. This is the graph for y equals x. You may label it. And then the graph for 2 plus e power minus half x. Okay. First thing we need to recall is what is the graph for ex looks like. It goes like this. Now we need to recall what the graph for e minus x looks like. That goes like this. The shape for e power minus half x would be similar. So this is the graph for e power minus half x. We need to add 2 to it, which means every point is going to go 2 units up. The asymptote is this horizontal line at 0. We're going to first send this 2 units up. So this is 1, this is 2. We make a dotted line around it. Okay. And this intercept, which was 1 initially, will also go 2 units up, which would now land at 3. And our curve would look something like this. Don't let this curve touch the asymptote. And we're done. The graph for ln x is like this. Something like this. There's 1 here, and the y-axis is the asymptote for this graph. Okay. Now I need to draw the graph for, this is y equals ln x. Okay, now we need to draw the graph for y equals 3x minus x squared. I will quickly find the x-intercepts first by making y 0 and taking x common. So I'm getting x equals to 0 and x equals to 3 as my x-intercepts. So 0 is here, 1, 2, 3. 3 is here. So I'll have a graph. Oh no, it's going to be an upside down U because it's negative x squared. So we'll have something like this. Supposed to pass through 3. Okay, slightly tilted if I could try and do a better job. So goes up and then comes down. This is better. So we're going to sketch both these graphs on the same grid. First, I'm going to show you ln x. ln x is like this, like we've just discussed. This is y is equals to ln x. Now, what does ln x plus 2 do is it moves the graph 2 spaces to the left. So earlier, this was our asymptote at 0. Now we'll have an asymptote at negative 2. So that was 0. This would be negative 1. This would be negative 2. So I'm making a dotted line that represents the asymptote. And earlier, the x-intercept was at 1. Subtract 2 from it, it lands on -1. And our sketch would be something like this. Okay. In case they ask for the y-intercept as well, because this graph is cutting the y-intercept, we would need to find that. For the y-intercept, we make x 0. So y equals ln 0 plus 2. So that's ln 2. So you can mark ln 2 here. Okay. Next is the graph for 4 times e power minus x. Okay. So we know e power x looks like this. And e power minus x goes like this. This is 1. And when we multiply this with 4, then the y-intercept would be 4 actually, because if I write 4 e power minus 0, that's just 4 times 1. So the y-intercept becomes 4 and the graph would go something like this. So 4 would be quite high. Let me see what is ln 2 and accordingly I'll make 4. Okay, ln 2 is actually a small value. So 4 would be significantly higher than this. So let's say somewhere over here. So the graph would go like this. I think I should have made ln2 slightly lower, but you get the picture. This would be 4. It would be nice if you could make ln2 slightly lower so that 4 makes sense. The scale needs to be constant throughout. So ln2 is 0.6. So that means 4 needs to be quite high according to that. So if this is 0.6, we'll have 1 somewhere over here, 2 somewhere over here, 3 somewhere over here, and 4 somewhere over here. So good idea would have been making this ln2 quite lower, something like this. This could have been our ln2, this could have been our negative 1. Anyway, you can fix that on your own. Next is question 9. We need to plot y is equals to 2 minus x and y is equals to ln x on the same grid. So we know ln x goes like this. This is 1. And y equals 2 minus x. If x is 0, y would be 2. Somewhere over here. And when y is 0, x would be 2 again. So somewhere over here. So the line is something like this. All right. Next is the graph for e power 2x. It's the same, the shape is same as the graph for e power x, so it's going to look the same. passes through 1 on the y-axis. Next is the graph for e power minus x plus 6. So we know e power minus x looks like this. It's a falling graph. And we have to make this 6 units higher. So let me make one smaller, lower, so that 6 fits on the same curve. So it's going to be something like this. Okay, so move this 6 units up. So 1, 2, 3, 4, 5, 6. So the asymptote, which was originally here, will now go 6 unit up, and it's going to be here at 6. Okay, so we have a 6 here. The y-intercept, which was originally 1, also goes 6 unit up, so it lands at 7. So the curve will look something like this. Don't let it touch the asymptote. So the graph for e power minus half x looks the same as the graph for e power minus x, which is like this. This is 1. Okay. Now we need the graph for y is equals to 4 minus x squared. To find the x-intercept, I'm making y 0. So I get x squared equals 4. So x equals plus minus 2. X squared equals 4, x equals plus minus 2. And since it's negative x squared, that means it's an upside down view like this. So if I have 2 here, and sorry, negative 2 here and 2 here, so we'll have a very symmetrical graph, something like this. And I would also need its y-intercept because it's cutting the y-axis. For that, I make x 0. So y is equals to 4 minus 0 square, which is a 4. So this is what the graph should look like.